Hey everyone, my name is Yangmin. I'm a software engineer at Google. I'm Istio maintainer, mainly working on the security side. I work a lot around the security policy. You may have already noticed. So today, my talk is about the better external authorization. So before we deep dive into today's topic, let's ask a simple question. What is external authorization and why would you even want to care about it? External authorization is to delegate the authorization decision to some custom logic that is not provided by Istio. So if you compare it with the Istio authorization policy, the biggest difference here is that when you are using authorization policy, you only need to write the YAML file, and Istio will take care of the remaining work, like enforcing it, making the authorization decision based on your policy. And when you are using the extra authorization, it's you that you need to write the custom logic that actually enforce and inspect the request and make the authorization decision. So why would you even need to use the extra authorization if Istio is already providing the first-class authorization policy? That's a very good question. There are a lot of answers here. I will just list some most important use cases here. So we have found that many customers, they need better extensibility in authorization to address those following issues. First, for example, you may have your in-house authorization system that is developed many years ago and accumulated a lot of legacy code, policy, infrastructure over the years. And all those things, they just cannot be simply replaced by Istio authorization. There might be another case that you just want to integrate with some third-party solution. For example, the Open Policy Agent, or OPA for short, and you have written some OPA policy, and you don't feel comfortable, or you just don't have the resource or time to migrate those OPA policy to, for example, Istio authorization, and you want to keep using OPA. Or maybe you want to integrate with this OS2-proxy project, which is an awesome project that provides integration with a lot of OS2 providers. And you just want to use it with Istio. The last but not least, you may want to, you may find that Istio authorization policy, it just lacks some necessary semantics for your use case. You do not need very fancy logic, but the specific expression is not available in the Istio authorization policy yet. All of these use cases, and the list goes on, it will bring you to this point that you need better extensibility in Istio authorization policy. So, okay, we understand the motivation here. Let's take a look at how it is being done before 1.9, and what are the pain points of the old approach for the external authorization. So before 1.9, it is usually solved by using the Envoy external auth filter combined with the Istio Envoy filter API. And it, of course, works, but it comes with some big pain points here. If you have used Envoy API with XOZ filter before, I'm pretty sure you already know what I am going to say, and there are a lot of issues here. First, let's look at the usability. Envoy filter is a very flexible and a powerful API. It allows you to do a lot of low-level modifications to the Envoy config that is generated by Istio. But on the other side, it is also very easy to make mistakes with Envoy filter. For example, you may have a mistyped URL in the Envoy filter config that just causes not adding the filter correctly. Another example is you may want to use Envoy filter to merge the bool value, and then you suddenly find out it's not working the way you may want. Last but not least, Envoy filter is a breaking class low-level API. That means improper use of the Envoy filter API, it could easily crash your Istio. Second, let's look at the maintainability problem of using Envoy filter. So Envoy filter API is generally hard to maintain, and the situation becomes worse in some specific cases. So when you are writing Envoy filter, you are not really using Istio API. You are writing the Envoy config directly, which means you are using the Envoy API directly in Istio. So that means any Envoy API change could silently break your Envoy filter API without prior notice. Because that is a transparent API in Istio, we cannot really do a lot of validation against it. To Istio, it's something like a transparent config that we just pass to the Envoy. And we cannot make sure it is always consistent with the Envoy version we are using. So it's the user's responsibility to make sure that the Envoy version used in Istio is consistent with the Envoy config that you specified in your Envoy filter. And sometimes you will even need slightly different Envoy filter in each different Istio version due to the Envoy filter API itself is like changing rapidly. It's still alpha API. And this becomes worse if you have a lot of Envoy filter API applied in your large cluster and very hard to maintain and scale. The third problem here is about troubleshooting. This is specific to the extra auth use case. Because you are writing the extra auth config, and due to the special use case of extra auth config, it has too much low-level details that you should take care of. For example, I will just give you one example here. If you are using gRPC with your extra auth filter config, the very first thing you need to specify is you need to figure out the cluster name that should be put into the extra auth filter config. However, the cluster name and its format, so here is an example that, like this example, it has this outbound pipe, the port number, and an empty string, and then a pipe, and then another service name. So this whole cluster name, it is an Istio internal implementation detail. This means it could be changed anytime by Istio, because that's not an API at all. And what's worse, if you need another, you would need another Envoy API, Envoy filter API, to rename this internal class name so that it does not include the pipe character. Because by default, the external auth filter will use that class name as the gRPC request host header. And in the host header, the pipe character is invalid, and it will be rejected in the HTTP connection level. This is mitigated by another field that is added to the Envoy extra auth filter config that allows you to override to use a separate host header so that it doesn't default to use the class name. But before that is available, you have to apply some like very hacky workaround to use a second Envoy filter to patch that host name so that it doesn't include the pipe character. Last, it's about the feature-wise. So when you are using extra auth, there is no way to trigger the extra auth flow conditionally. And well, technically speaking, there is a way to enable or disable the extra auth using the per route configuration. But if you are using Envoy filter API, that will be extremely difficult to use, because now you are not only modifying the field config, you have also need to mess up with the Istio route configuration, which is a very complicated thing that I have not seen people doing it correctly so far. This means you cannot really enable or disable the XORC flow for a specific route based on things like path, host, IP, etc. This is actually a very common use case for XORC as well as for other like authentication or authorization. Sometimes you just do not need the XORC for things like health check. So you want to skip the XORC for that health check. And you cannot do that with the old approach using Envoy filter API. So this list goes on and on. And I think if you have looked at some other presentation in this IstioCon, you will find that there are a lot of people, they are seeing that the difficulties they are using Envoy filter. But let's make it very clear. I'm not saying that you should never use Envoy filter API. The Envoy filter API, it's very useful and it has its legit use cases. But here is a big but. It is not the proper API that you should use for a critical security feature in your production environment at scale because of the usability, maintainability, and troubleshooting, and feature-wise, all those things makes it not a proper like API that you should depend on for your production usage. So this really comes to the question that we really need a better first-class support of this extra OC, or we put it more general that we need a better support for extensibility in the authorization policy. And you got it. That's what we are doing in Istio 1.9. We hear the user request, we hear the user complaints, and we hear and that's the result. We really focus on the authorization extensibility. We are providing infrastructure level and first-class API support of better extensibility in the Istio authorization policy. So here I will just focus on the two biggest changes in this feature. You will find more details. I will provide a link later in the slide to the original design doc. But here I will just focus those two things here. The very first change is that we now have added this custom action in the authorization policy. It allows you to specify where and when to trigger the extra OC service. And in this authorization policy, you will also need to refer to the extension provider by its unique name. So talking about the extension provider, that's the second biggest change we are making to support the extensibility here. We have added this extension provider concept in the mesh config to allow you to specify where and how to talk to the extra OC service. So each extension provider has its unique name and it will be referred to by the authorization policy. And currently, we support the extension provider of type Envoy extra OC filter. So you can see the Envoy extra OC filter is actually a concrete example of like using with Istio authorization policy to demonstrate the extensibility. And let's look into the API example. And we can show you here. The left side is a very normal authorization policy. You can see we give it a kind is authorization policy. We give it a name, extra OC, and we put it in the Istio system namespace. And it is using this selector to select the ingress gateway. And here, then it comes to the new changes we are adding in 1.9. We have this action that is called custom. This custom action will allow you to delegate the authorization check to this provider identified by this unique name. Here, I give it name like my extra auth service. And this action is triggered under these rules. So this specific rule, it means it will be triggered for request path if the path has the prefix /admin/. We are using the star wildcard in the end of the string to denote this is a prefix matching. And this rules is exactly the same rules that you might already be using in your existing authorization policy. So the really delta here is this like a custom action and this simple provider with a simple string name. We are intentionally making this design decision to make it simple that you don't need to worry too much about in your authorization policy. That's basically just two fields you need to take care of. And then let's take a look at the extension provider on the right side. So currently, this extension provider is defined in the mesh config for the current stage of this feature. You can see we have this extension providers field. It is a list, so you can define multiple extension provider, and you can use just one of them at a time, or you can use many of them. Let's look at this specific extension provider. So here you see the name again. It has this name, my extra auth service, which should be used by the authorization policy. You can see we are referring to this name in the authorization policy. And then it goes to the type of the extension provider. As I mentioned earlier, we support two types for now. The first type is the Envoy extra auth using HTTP interface. The other type is the Envoy extra auth using gRPC interface. It's pretty much the same as this one, but with some other detailed configuration. So let's take a look at this example. We simply give it a service name. Here, I give it this extraauth.full.service.class.local. This means I have deployed my extraauth server in the full namespace, and it is serving the extraauth check request on port 8000. And then it comes with some detailed configuration of the Envoy extra auth filter for things like what should be sent to the extra auth service, what should be sent to the upstream backend. Here, I'm only using one configuration that we should include this header when we are sending the request to the extra auth. So combining those things together, that's basically all the things you need to use the extra auth in Istio 1.9. You define the extra auth provider in the mesh config. You refer it in your authorization policy, and in your authorization policy, most fields they are exactly the same as you are already using them before. You don't need to learn a new matching rule. It's the same authorization matching rule that should make it easier to adopt in your use case. And if you want to customize your extra auth, you can put it in this extension provider for things like include the header in check, include the header in like a backend, things like that. You can also customize like the status returned by the extra auth when it failed the check. We pretty much provide almost all the configuration that you will find in the native extra auth filter itself. So let's take a look at the overall architecture of how like every piece of this configuration fits together. So first of all, you apply that authorization policy and you configure the extension provider in the mesh config. IstioD will then will find your configuration, it will process your configuration, and then it will distribute the Envoy config to the workload selected by your authorization policy with the corresponding XOC field config. So at this point, you have already deployed the XOC filter to the Envoy sidecar without using Envoy filter API at all. Then let's look at the runtime behavior. In the runtime, a request hits your front-end service, and then it will be checked against the authorization policy. If it is matched with the authorization policy, for example, if you have this authorization policy, if the request it indeed has the /admin/ prefix in their path, it will trigger the extra OC flow. And in this case, the extra OC filter will make a auth check to your extra auth service. And this extra auth service will be hosted at this service at this port that handles that extra OC check. Inside your extra auth service, it will do whatever it needs to do to process the request and make the access control decision. That decision could be either allow or deny. If that is a deny decision, the request here, it will be denied immediately without further processing. If that request is an allow from the extra auth, the request will still need to continue. It will still need to continue to go through the other authorization policy that you may have applied in the front service in your sidecar. So that basically means if you have custom action, delay action, and allow action all applied at the same time for the sidecar, the request will be denied if any of that action denies the request, and it will be allowed if all of them allow the request. So after it is really allowed, we will just continue forwarding the request to the backend, and your backend will process the request as is used to be. So that's basically the whole flow of integrating the extra auth service into Istio. Okay, so let's take a look at the benefits of this flow. First of all, you probably have already noticed that there is no more Envoy filter at all. The only API you need to configure is the authorization API and a small configuration in the mesh config to define your extra auth provider. This is much easier use and simpler for troubleshooting, because you no longer need to deal with all those like Envoy filter low-level details. Second, and more importantly, this is a first-class API support from Istio. It is much more reliable and stable. That means changes in Envoy will not break your configuration in Istio, because technically speaking, you are not using Envoy API at all. You are now using Istio API, and Istio will handle all those changes behind the scene automatically for you, because we will maintain the stability in the Istio API. And the Istio API is supposed to be used by the end user, which is different from the Envoy API that is supposed to be used by machine instead of human being. The second biggest benefit here is that the same configuration will work stably during upgrades in different Istio versions. Well, strictly speaking, this feature is new in 1.9. It is still in experimental stage, so we may still expect some changes based on user feedback, and until we promote this to alpha and beta. But that will be the direction of this API. And once it stays beta, we will have strict and strong backward compatibility support. Last, this API is part of the authorization API, and it is well tested, maintained, and supported by the Istio team. That's another big benefit if you are planning to integrate Istio with extra authorization. That simplifies the integration part, so that you can focus on your extra auth part instead of the integration part. Last, it also provides you a very nice feature that it allows triggering the extra auth flow conditionally. So now you can say something like only trigger the extra auth flow for host like example.com, or only trigger the or trigger the path for trigger the extra auth for all paths except the slash health. You may have this slash health as endpoint that you want everyone has access to it, and you can do many similar things here. Okay, so I have included all those important information about this feature in this slide. I will also share this slide to the IstioCon community once this presentation is done. You can find the original design doc. You need to join the Istio team drive access for access to the design doc. That's a very detailed design doc that includes all those design decisions we made, the trade-offs we made, why we are doing it like today, and implementation details, pretty much everything about this feature. You can also find the very useful end-user documentation. We have published a blog post for this feature, and it gives you an example integration with OPA, which I will soon demo after this slide. And you can also look at the task page for using the custom action. It shows you how to integrate with a sample extra auth server that is also implemented as part of sample server in Istio. You can use that as a starting point to plug in your customer logic and push it to your production. And if you are interested in the API, you can directly look at the formal protocol definition of the API for both the custom action and the extension provider. And last but not least, and actually very important, we really appreciate your feedback. Please really let us know your thoughts, your suggestions on this. We are working hard, and we are working continuously to improve it in the following releases. And this is a perfect time to provide your feedback. And if you want to see some changes in the API, or if you want to see some features to be supported by this use case, because currently we are still at the experiment stage, and it gives us a lot of the opportunity to improve this API without worrying too much about the compatibility issue. So feel free to provide your suggestions either in discuss.io or file an issue on our GitHub. And I thank you so much in advance. Next, I will give you a demo of using this extensibility. So this new API in 1.9 allows you to integrate with many extra auth solutions like OPA, like OS2 proxy. And I think it's very important to mention the difference here, that when you are using OPA, OS2 proxy, or any other things, those things are also scope of Istio. They are not maintained by Istio itself. Here we are just providing the infrastructure level support that makes your life much easier to integrate with your like extra auth solution. But please remember, if you find any bugs in your like extra solution, you should file your bugs against your extra auth solution instead of Istio. But if you find anything like regarding the integration part, that part should that can go to Istio, and we will handle that properly. Okay, so let's look at this demo. So I will deploy OPA in the default namespace as the extension provider. In the user case, it is usually maintained by the customer. And in the Istio mesh, I will deploy the workload and with the Istio proxy, and I will use authorization policy to delegate the authorization check to the OPA port. Okay, let me switch to the terminal and to show you the demo. By the way, if you look at the blog post, we actually have the full detailed instructions for integrating with OPA as an example. Okay, let me just show you some basic status in my Kubernetes cluster. You can see I have already deployed the example HTTP bean, the example sleep. That's just the example sleep and HTTP you will find in every Istio task. And I have already deployed this OPA in the Istio cluster. You can see it has two container, which means it has the Istio proxy injected. Let's take a closer look at it. Yeah, you can see we are using Istio 1.9. The proxy is injected correctly, and we are using the latest OPA that is specifically built for the on-way integration. Because you are using OPA, we also need to deploy and create the OPA policy. And currently, I have deployed this as a secret in my cluster. You can see there is a OPA policy secret. That is just an example of OPA policy that I deployed for the customized logic of access control. Let's take a look at its content here. Let's copy out this basis for encoded string and decode it. Okay, here you can see we have an example OPA policy. It does some like a custom processing of the JOT token in the request, check its fields, and compare it against another field in the JOT token. This customization currently is not supported by Istio authorization policy. That's one of the reasons you may want to use OPA like for things like this. Now let's start to enable the integration with this OPA. Before we do that, let's confirm that our sleep port is able to talk to our HTTP bean port. So you can see for the 3 requests, we are all receiving 200 HTTP response code. That means we are not using the OPA at all. As you remember, the very first thing we need to do is to define this extension provider. We need to tell the Istio that, hey, we want to use this extension provider. And here is the detailed information that how you can talk to that extension provider. So I will configure the Istio config map to add this definition. Oops. I can just add it here. And then save and exit. Normally, Istio will pick up the changes in the mesh config automatically after like 1 or 2 minutes. It's a bit slow because we are mounting the secret instead of watching. We're mounting the config map instead of watching the config map. So to make things faster, I will just restart IstioD. But in your use case, you don't necessarily need to restart your USD. You can just like wait maybe 1 or 2 minutes to get it updated. And if we later improve this study to use the watch API, it should find this change much faster, maybe in like under 10 seconds. Okay, the new study is now up and running. And then we can just apply the authorization policy. Before we do that, let's take a quick look at the content of the authorization policy. You can see we are applying it to the HTTP bean workload because we want to enforce the access control for the HTTP bean workload. We are giving it the custom action so that it will dedicate the authorization check to the OPA container. And here we are using the extension provider that is called OPA.default. If you remember, that's the extension provider we added to the mesh config. And we want to trigger this extra flow if the request path is not /IP. You can think of this /IP as some like a health check endpoint that do not need to be protected by the extra auth. So let's just apply this. Okay, it's applied. Usually it will take a few seconds for the policy to propagate. So let's try to send the request first to say if it is already applied. It's not applied yet. Let me send the request again. Okay, it's now taking effective. Let's take a closer look at the first request. The first request is that we are sending a request to this path /headers from the sleep pod, and we are not attaching any jot token. And then you can see we are getting this 403 because OPA is rejecting the request. Second, we send the request from the same sleep pod to the same /headers, but this time we use a special token that will be accepted by OPA. And then you can see we receive this 200. This is returned by because OPA allows this request. Last, we are sending again a request from the sleep pod to the HTTP bean, but at a different path, at the path IP, without the authorization token. You can see we don't specify the authorization token like here. And it is still allowed. This is because we specified the not path IP, which means the request, it doesn't even trigger the extra auth at all. OPA does not say this request at all because we don't want it to trigger the extra auth flow. And we can check the logs in the OPA container to confirm that it is actually enforcing all those requests. Container OPA. You can see it's a little bit hard to see, so let me just search this and pass it to JQ. So if you have used OPA before, you might be already familiar with this decision log. This is a log printed by OPA when it is making an access control decision about a request. You can see it has this unique decision ID. And from this input, you can see the request inspected by OPA. It is a request sent to this destination that has this HTTP bean from this source that has this sleep principal. So OPA knows this request is from sleep to HTTP bean, which has this path /headers, but it doesn't have this authorization header. So it gives a decision that it should be denied. The result is false. For the second request to /headers, it has this authorization header, and then it is giving this decision allow, result true. That's the only two decision made by OPA, which also proves that it is not seeing the request for the path to /IP. Okay, that's pretty much all the demo of using the OPA with this extensibility in Istio 109. As you can see, you only need to configure the mesh config and then apply the authorization policy. So thank you. That's pretty much all from my side. And thank you for your time. And we look forward for your feedback and associations on this feature.